In this video, we're going to talk about sampling error concepts. The primary concepts that we're going to be looking at are, first of all, what is sampling error? So sampling error is the difference between the sample average and the population average. So in theory, when you just look at the wording, sampling error, so how far does the sample differ from the true population? And so we're going to be looking at the averages in this case. So X bar is your sample average, and the mu, that's M looking symbol, is your population average. There are going to be three things we're going to be looking at in Excel. One of them is finding the sampling error for a random sample of size 10. Second, we're going to go ahead and do the range of potential sampling errors if 10 people are sampling. So you're going to take your lowest 10 values and your highest 10 values and figure out what the sampling error is. It gives you an idea of how much error you could have in your sample. And then last, we're going to see what happens to sampling error when sampling size increases. So in Excel, let's go ahead and look at the GPA of current business students. Keep in mind this is all hypothetical data. So in this example, we want to find our sampling error. So X bar minus mu, our sample average minus our population average. So our overall population mean is equals average. We're going to put in our sample range, so we're going to go shift and down, and it's going to highlight all of the ranges that have data in them. So our overall mean is a 2.80. And then we're going to need to find a sample and do our sample average. So we want to do a random sample. So if we're going to do a random sample, there are two ways to do this. I can do data and data analysis, and there's a sampling option within this one. If that doesn't show up when you try and get to it, so data analysis doesn't show up, what you're going to need to do is you're going to need to click on File. Keep in mind this only works if you're working on a PC. If you have the Mac version of Excel, I'll show you another way to get a random sample. So we're going to do File, we're going to do Options, we're going to click on, in Excel options, we're going to click on Add-ins. In the add-ins on this page, it says Manage Excel Add-ins Go. So right down in here, so we're going to go ahead and click on Go. You're going to click on the Analysis Tool Pack, and you're going to click on OK. And when you do that, the data analysis pack should be there. So the analysis tools in this one are alphabetized, so sampling. We're going to click on sampling, and now next we need to do our input range. Now I've already been playing around in this, so my ranges are automatically pre-highlighted. That won't happen the first time you go in. So we're going to need to define our input range. So I want my title in there. So remember I included the title, so I'm going to do Shift and down. It's going to catch up all of our data. There were labels in it, so you're going to click on the labels button. I want to do a random number of samples of size 10, and I want my output range. Normally it's defaulted to new worksheet ply, so I want my output range to go ahead and be, in this case, let's do G2. So random sample, here's my data. There were labels of size 10, output range is G2. And there it did it. It went ahead and sampled 10 people. So if we would have randomly sampled 10, this would be what their GPA would be. So we're going to find the average of those 10. So the average GPA out of those 10 is a 2.57. Well, given that our overall mean for our whole population is a 2.80, it means that we did a sample of students who had a lower GPA than those of my whole population. So sampling error is X bar, so 2.57 minus our mean, 2.80. So our sampling error is a negative 0.23. So our GPA was 0.23 lower than the population mean. Now what we're going to look at next is what happens if you didn't have the data analysis tool pack. So if you didn't have the data analysis tool pack, I'm going to go ahead and insert a row right here so that I'm not messing with any of the data on the other side. So let's go ahead and we're going to put in a random number here. So you're going to do equals rand with the 2 parentheses. And when you do that, it's going to come up with a random number between 0, 1, some very long decimal point. So because we're working in a table format, I can double click on this little box on the corner and it's going to fill all of them in. Now, anytime I click on any button in here or add any other set of data, you'll know that they all change. So I want to lock those values in. So I'm going to go ahead and say insert, it's not insert, excuse me, I want to say column B. I'm going to say copy. And I'm going to do paste values. So I'm going to do paste 1, 2, 3. That's the same thing as doing paste special and doing values. So now instead of equals rand, I have values within there. So let's do a sort of these now, and let's go ahead and say sort. Do a custom sort by my random number. Do OK. There are other ways to do sorts. I do recognize that. I could have clicked on here and done sort from smallest to largest and it would have done the same thing. So we now have them in completely random order, but from a GPA standpoint, but from a random number standpoint, we want the lowest 10. So what is the GPA of our lowest 10? So you can either watch your screen on the top. It says 10R by 1C, or you can highlight your range of values and you can see that, well, not what I wanted. There's a count of 10 down here. So I'm going to do Control C and Control V. Now when I paste over this, keep in mind, it just says, okay, we're going to do a second random sample. When I did that random sample, I found my sample average was 2.75 or 2.76, which is then going to be minus 0.4 difference than our population. If I did another random sample, it might be 0.8, 0.3, 0.2, negative 0.5. So it's going to have a lot of different ranges in there. So what is our range of sampling errors? So let's go ahead and do our lowest sample and our highest sample. So instead of doing a random number, so I'm going to delete that column, instead of doing a random number, we are literally going to take our column A and we're going to sort it from smallest to largest. So my smallest 10, copy, paste, Control C, Control V, and my largest 10, Control C and Control V, are going to have a far different output because they really are going to show us our range. So equals average of my lowest sample is 0.69. So my sampling error is negative 0.69 minus 2.8. So in this case, it's negative 2.11 difference. So it's over a 2-point difference in GPA. That's huge. And then when we look at our highest one, because I had done the formula in there, I can do Control C and Control V and just double check it's highlighted. If we look here, I2 to I11, I2 to I11, which is where our data was. So it worked just fine. So equals my lowest minus my, my sample average minus my mean is 1.16. So if I were to go ahead and state what the range would be is based on a sample of size 10, the sample average GPA will be higher or lower than the overall mean by difference by negative 2.11 or 1.16. So if we were to look at this one And let's go ahead and figure out what this piece is. We're going to go ahead and look at this one in just a second on a larger scale, but I took my data and I put it from low to high. I did a sample of size 10, found that my average was somewhere in the middle of those. I did my highest sample of 10 and found that my average was somewhere in the middle of those. So my range of sampling errors for my average is going to range then between there and there. What happens then when you do a larger sample? So if we do a sample of size 20, so let's go ahead in this example, say I have 65 in my population. I'm going to change populations on you just a little bit here. So sample of size 10 gets me a range of sampling errors between there and there. So if I would have taken a sample of size 10 randomly, my sample average could have been here. It could have been here. It could have been down here. So depending on what sample of 10 is taken, I'm going to find myself all over the board on this one. So what happens if we increase the sample size? So if we increase the sample size, let's say we're going to do a sample of size 20. So again, my data is sorted from low to high. I'm going to go ahead and take a sample of size 20, which would put my average here. I'm going to take a sample of size 20 of my highest and do it at the top. And then our sample average of our 20 is going to be somewhere in there. So our sample error is going to decrease. So you're getting closer and closer to the mean. If I do a sample of size 30, it's going to be the same thing. So a sample of size 30 means my sample size is larger. My average is going to be here. So just like the last examples, I'm continue to get smaller. Sample of size 40, I continue to get smaller. And if I did a population sample of size 60, so if I did a sample size of 60, keep in mind my population size is 65, not much of a difference, but my sample average, so I take my 60 here, and my sample average is going to put me somewhere in there. If I take all but my lowest, I take out my highest 60 and do my average, I'm going to find I'm somewhere in here. So my range on this one is going to be somewhere in there. So my sampling error is going to continue to decrease. What does this tell you? That tells you two things. It tells you, one, the larger your sample size, the smaller your sampling error. And the other thing that it also tells you is that we can take samples. And so if I take a sample of the size 10, I might find that my average is here. So a random sample. If I take a random sample of size 20, I might find that my average is here. If I take a sample of size 30, just completely random, that might be in here. Sample of size 40 might be here, and sample of size 60 might be there. So if you look at the values you're going to get out of them, you might take a sample of 10 and still be closer to your sample average than you would with a sample of 20. That's just a fluke because these red bars are random samples. So your ranges are going to help determine how close you're going to get to that mean. But you'd never take a sample of size 40 and get an average down here. Hope that helps, and I'll catch you in the next